So yeah, just to continue. A very recent paper is a survey paper written by well, two researchers from UK on explanation-based human debugging of NLP models. If you look at the title, it basically captures all those important keywords that we are also discussing all the time, right? Explanation, debugging, and NLP. So before I start, let me maybe first, well, to make it also more interactive, right? To first ask everyone here what, why, and the how. Before we really dive into this content, the survey is long. If you take a read, it's a lot of pages. Here, the authors make the 17 slides, but it's super, summative. It's actually a lot of content. So I think it's important that we have, we ourselves, right, we can gain a good overview of what's written, what's discussed here before we dive into those details. So to start, I like us to, well, first to think about what is debugging, why we want debugging, and how do we do that? I mean, there's a clue here, right? We do it by explanation and using humans. So there's a clue here. But yeah, what's our view to this? I think that is important. So for some of us here, work that we have been doing is closely related to this. Agath, for example, and Lorenzo and Philippe, actually also Paula, right? Also Paula, it's quite related. And actually a lot of the things that we have discussed, you can find those authors discuss as well in this paper. So who wanted to first say something about what is debugging? Maybe Agath?
Yeah, sure. I mean, at least according to what we do in our own work, it's about finding whether the model is following certain requirements that some human, typically experts, would give to us. Traditionally in software engineering, it's either about proactive or reactive debugging. So reactive debugging is when we know that the system is failing in some way, but we need to identify what is the actual cause of it, so the bug. Whereas in proactive debugging, we typically don't even know that there is some failure, and we need to actually search for this failure before being able to search for its cause or the bug.
I see. Yeah, so it's so you, okay, you are now giving more information than the definition, right? You're talking also about the workflow, and we'll come back to that. So debugging, basically it's two words, right? Debug, right? So debugging basically involves two steps. The first step is that we identify what the bug is, and then we want to mitigate this bug, right? And this is what what's also discussed in this paper. So the term debugging, right, is interpreted differently. Well, some considers the bug identification, right, identifying the causes of model errors. And someone further considers also the fixing or mitigation of those bugs. And that we can agree. But what kind of bugs do we consider here might be very different from our general idea of bugs in software engineering. So in software engineering, we usually consider bugs as those errors in the code, right? Those well, variables, those control operations that we have, if while for something like that, right? But in the machine learning model, it's quite different because we don't really have these explicitly coded rules, the mechanism, right? How the system works, we don't really know. That is why we consider explanation as one of the most important things here, because we want to first gain an understanding of what's going on in the model before we can identify any errors in the model. And then I've seen these, there are different discussions of the types of bugs in machine learning models. And that's, I think we have, different people have different opinions about that. The bugs could still be about the bugs in the code, right? The training code that we write to train a model. And the bugs could also be about the data, right? Problem is the data. These, for example, all these biases that we talk about that can cause what people call spurious correlation. Basically, it means that, okay, bias in the data can lead to those wrong correlation that the model then picks up, and then it uses it in the prediction. And this is actually one of the most common type of bugs that, and might be most challenging bugs that we needed to address in this debugging processes. There are other types of bugs like labeling errors. Like this is something that we haven't really talked much about in for people here, but it is also one of the important problems that we might encounter. Also, out of distribution, right? This is something that basically says it's similar to bias in the training data. Both can cause spurious correlations. But out of distribution is less about, okay, what's going on in the training data, but rather about, okay, what if the situation changes after the model is deployed? What if different types of data are encountered by the model, and then the model would make errors because it learned from the past, right? So if there's anything that causes this out of distribution, then we are facing those potential errors that the model might make. So cool. So we discussed about the what and the why, right? I guess this is nobody really has a problem. I guess here have any questions? And machine learning models are used everywhere, right? But they also fail everywhere. We have heard all these terrible stories, right? Autonomous driving, car hitting a pedestrian, automated trading. Those automated trading bots, they cause some, a loss of 20 million euros per day for investor. In medical case, that can be even worse, right? So there are all these reasons why we want to do debugging, especially if we compare that, I mean, from a research perspective, if we compare what we have been doing, what we have done in debugging machine learning models to what the researchers have been have done in debugging softwares, you can see that there is a big gap, right? In software engineering, debugging or software testing is a big topic, a really big topic. But then in machine learning, it's not that much that you can find, right? It's far from so machine learning so far. If we use big words, like it's more an art than a science or engineering discipline, right? The way that we do machine learning nowadays is simply, well, let's go collect as much data as possible, and we train a machine learning model, and then whatever performance we get, that's what we get, right? It's not much that we can do beyond that. It's not like software engineering, right? So where okay, we have requirement analysis, specification, or design, development, test, debugging, right? Maintenance, all these steps. Machine learning, we don't, right? If you compare these two disciplines like this, you can see actually there's a lot of things that we need to do in machine learning so that it becomes something that we can really some more it can become some more engineering discipline, right, where humans can have more control. And that I have by discussing all these things, I think I have covered the main the introduction of this survey. Now let's jump to already to the general framework of this survey, basically a framework that authors propose to use as a lens, right, to look at all this debugging work. So now it contains three components, right? In the debugging, the author proposed that, okay, there are three things that we should care about. Well, actually, there are two things, right? The model and the human, but then there are three main steps that we should be concerned about. One is the model provides, or through some explanation methods, we provide explanations to the humans. And then the humans give feedback on, okay, where things are going wrong, where we can do better, right? Give feedback, and then we can update the model. This is super, very high level, right? But it provides a good staging of the different steps that we might take in the debugging process. So another question that I have, right, for you is, so what are the roles that humans are playing here? So why do we need human, right? And then what are the roles that humans can play here in the debugging of a machine learning model? Anybody wants to say something?
I can take this, excuse me.
Yeah,
I can
sure.
take a stab at it, but I'm not sure that I'm right. But to me, the immediate idea would be to correct any wrong pathways that the model might begin taking in terms of explaining what it's doing. So if you're trying to have it do a particular, like a classification as the most simplistic, if you're trying to have it assess or classify a specific thing and it's going the wrong direction, the human can kind of give it hints to move it back towards where it should be going.
Thanks, Garrett. Exactly. Now, if I ask you a little bit, or dig into it a little bit further, right? So who would be those humans here? If you imagine, right, in a practical setting, so who can be this human?
I guess that depends on whether you want general human feedback or whether you want expert human feedback. And if it's expert, it would depend on whether or not you are, like, what field you're in. You're going to want to have to dig up, the experts for that particular field, which become a limited resource. So I guess the answer is it really depends.
That's a good point, right? That's a good point. Sometimes we might need some domain knowledge, right, in the debugging, and for that we need experts. And in some cases, it could be general users, right? Now in general, there are different types of humans involved in the life cycle of machine learning, right? First, there is this annotators, for sure. We need humans to provide the data, and then the developers, right? The developers who might have different names or titles in industry. They could be what we call data scientists, machine learning scientists, software engineers. There are all different names that, and it's used very differently in different companies. So there are developers here involved as well. And there are also users who, well, maybe not necessarily going there already. So there are also those program managers or project managers, right? Who, if you think about the general setting of information IT company, right? That we usually within the company, there usually is a software engineering team, and also some people who are more responsible for the running, for the operation of the system. Those program managers, project, I'm not sure how they are called, but they have also different names. And these people sometimes are the domain experts, right? These people sometimes are the domain experts because they care more about the use of those systems when facing the end users. And then talking about that, there's of course these end users who are affected by those by the use of those systems, and sometimes even more, right? Not only the users but also the stakeholders, right? If you think about, for example, use case of machine learning in a hospital setting, right? If there is a image recognition algorithm used to classify, okay, which patient needs more care based on the medical images, right? Then there is not only those patients who are affected, but also the families, right? So there are also people who are affected, right, on a broader scale, broader scope, who are affected by the use of those machine learning systems. So yeah, there are all different types of humans that they can all be involved in giving the feedback. If we think about the different types of humans, people, let's say people, it's a more humanized way of saying human. So if we consider different types of people involved in this debugging process, now for different people, different types of people, the explanation that we provide to them, right, in this first step, providing explanation, that might be different. We might need to consider different types of explanations. Some of them might be able to understand more complex forms like rules, right? For example, the doctors, they should be able to understand the rules of diagnosing a image or disease. Some users might be less comfortable with this kind of complex forms of explanation. So there are all different factors that we need to take into account from the human side in determining, okay, which kind of explanations we want to provide. And if you look at the literature, there are all different types of explanation. There can be, well, for example, in natural language processing, right, there can be those words highlighted by some feature attribution methods that Lorenzo actually was presenting about that yesterday in the morning, right? It could be others, like, okay, we can provide, instead of providing, showing, okay, where in the original input the model is looking at in making the prediction, we can also show some similar examples, like some examples where the model is having a similar behavior, like the input and output are similar, right? And in this case, the user needed to parse those examples themselves and to extract some common concepts, right? Common understanding of, okay, how exactly the model is working. And there are other types of explanation as well. For example, rules that I was saying, right? It's more abstract way of describing the model behaviors. So there are different types of explanation that might fit for different types of well, people involved in the debugging process. And the interactivity here is actually also a very important thing, right? What kind of interactions we want to provide such that the people who are involved here can well, smoothly understand what's going on in the model inference, and then provide feedback as you want, right? The way they want. So how can we do that? Now, interaction here is also quite important. So here is, I mean, here, this is actually, if you think about step 1 and step 2, right? Providing explanation and giving feedback. This is very much connected to the human AI interaction topic that we'll be discussing, right? Only that this is a very specific scenario of human AI interaction. So everything that we study there, we can think about, okay, how that could be, all those insights that we have found in general human AI interaction studies can be transferred here. So these 2 steps, I think, are the key steps here. And then the updating the model, I don't think we are that much interested in this yet, and for the folks here. But for, I think this is this topic has then been also quite much discussed, or is being discussed in the machine learning community, right? There are different ways of updating the model once we get human feedback, right? Getting new data, new training data, right? Updating the objective functions, updating the hyperparameters of the model, right? Or we can even have now pose some constraints to the model architecture itself, right? By, for example, adding some regularization layers to the intermediate neuron layers, right? There is that kind of magic thing that we can do as well. But yeah, so if you're interested, you can go and look further in the paper. Yeah, I think I have touched upon most important things here, at least from my perspective. Of course, I would strongly encourage you to take a read, go through the paper. It has much. Oh, can you? Oh, you are still seeing my slides, right? Okay.
Yeah, you can see.
Okay, cool. There is something flashing. I was thinking if anything went wrong. Okay, cool. So yeah, if you're interested in going deeper in each of those steps, I would strongly encourage you to take a look at the paper, right? Now, this is more natural language processing stuff. What I was talking about, I think, is more general, right? It's not only applies to NLP, but also to many other machine learning problems. But then this paper is, I think, is published in ACL, right? NLP conferences. It's really only focused on the in the actual discussions. It focuses more on the NLP tasks. So it discusses the debugging in different from different dimensions, right? One is context. Maybe I can. Oh, it tries to categorize the work in different dimensions: context, workflow, and human factors. These are all about human factors. So what I find nice is that it really talks about human factors. It appears to me that these authors might also be interested in going deeper on that side. So eventually, I think it might be a good idea to to invite the authors to give a talk, because it seems that they have a very they have interests very much overlapping with what we have here. But anyway, coming back to the actual content, so the authors categorize the existing work first by context, and by context they were mainly referring to, okay, first of all, natural language processing tasks, machine learning models, and what are the sources of those bots, right? The task here could be, actually what they find is that most of the existing work, they focus on text classification tasks because it's simpler, right? There are a few papers that they find on natural language inference and the question answering. Natural language inference, for folks who are not quite familiar with NLP here, so what these tasks do is that, well, given a premise and a consequence, I think, to see if the premise entails a consequence, basically some causal relations, if I'm not mistaken. I haven't had much experience on this, but this is generally what I understand about natural language inference. And then question answering, right? Given the question and some context, like a paragraph, right, where the question is made based on, if not, or what kind of answers the model can give. And this you can link to applications and conversation agents, right? That a lot of us here are familiar with. So when there is a question from the customer, for example, in some commercial setting, when there's a question from the customer, can the machine learning model automatically generate answers based on some data we have, right? For example, some historical question answering, some document, right, sitting in the back end of the system. So this is what question answering does. An interesting finding by analyzing these tasks is that, well, first of all, right, people focus more on the text classification, as I mentioned. Not much on other types of NLP tasks that could be quite interesting to look into. Natural language inference, for sure. Question answering, that's also interesting. And also there are many other NLP tasks like translation, simplification, right? If we think about the topic of inclusion or inclusivity of those machine learning systems. Well, we might, I mean, techniques like text simplification could be super interesting, because I mean, yeah, the whole goal here, the whole idea here is to simplify the text so that more people can read, right? And that's actually a quite interesting setting, and we currently have some students working on that topic, and that's something I think Lorenzo is also going to take a look later. So takeaway message, right? There are all different kinds of NLP tasks that we can look into. And then in terms of models, well, I mean, for folks who are familiar with machine learning, right? This is actually all the path that the machine learning community has taken in terms of different models being focused on in their research. So we started with traditional models like naive Bayesian models, logistic regression, right? Those simpler ones, to neural nets, and now to more those language models that are pre-trained. And these things, Stanford people call them foundation models, and they have actually quite a interesting white paper written recently on what we need to do about those foundation models. And the key points there was well, transparency, right? Explaining how the model works, reliability, right? When the model fails, and also bias, right? These are the things that is topics that are being discussed in other parts of the world as well. So what's nice about these language models is that they are not basically, the same architecture is not basically applied everywhere, not only in natural language processing, but also in, for example, computer vision, right? If you look at these recent papers from computer vision, a lot of people are basically applying the same techniques that has been developed in NLP transformers to solve all different kinds of computer vision problems, object detection, segmentation, tracking, right? All these different computer vision problems. So these kind of models are being, you can find it everywhere. Now, if we have a way of debugging those models, then there's a huge impact that we can make, right? So I think there's a much more interest in, choosing those models to debug in terms of research, at least, right, than debugging the other types of models. And some of the models, there isn't much to be done, actually, like those logistic regression or Bayesian models, because I mean, those models, they are more self-explanatory already. There isn't much to be done in terms of explanation. But if we do want to study more on the human side, like how humans can consume those explanations, what affects the uptake of those explanation technology, right? Well, for those cases, we need, if we want to have a better controlled experiment, then those traditional models might be more interesting to us. And later, the author talk about bug sources, right? Natural artifact. This is exactly I think we're talking about that. So this is exactly the spurious correlations that is caused by bias in the training data. And there could be other bug sources as well, like we discussed. One interesting finding that these authors have is that they find that there isn't so much work in NLP debugging, that where the bugs are created, right, for experimentation purpose, where the bugs are created by manually injecting those artifacts or those biases. And in computer vision, we do that a lot. And that, I think Agathe has a very, well, can feel very related to, right? So, so one big challenge in developing and evaluating all the explanation or debugging methods is that we don't have this ground truth that we might have in other cases, like when we develop a machine learning model, we can evaluate their performance by comparing the output against the ground truth labels, right? And by doing that, we can say, okay, this machine learning model has an accuracy of 90%, something like that, measurement that we can say how good the model is, how good the architecture is, like if the goal here is to come up with a new architecture, right? But if we do research on explanation or on debugging, if we wanted to introduce a new method, right, for explanation or debugging, how can we show this is a good, right? Do we have a metric? Well, for that, we need to first know, for example, if we want to propose a new explanation method, we need to know first how exactly the model is behaving, right? So that we can compare the explanation that we get from our explanation method to the real behavior of the model, right? But in those cases, I mean, but the challenge here is that we don't know, right, what the model is doing, and that is a big challenge for us to validate the explanation or debugging method. So one way of addressing this problem, and computer vision at least, is that, well, what we can do is we can manually inject some or decoys or biases or spurious relations into the training data to make sure that the model picks those up, right, in the learning, and so that we are sure that there is a certain type of behavior of the model that then we can use to validate our explanation method, right, or debugging method, to see if our debugging method allows us to really identify such pre-injected errors, right, in the inference. So apparently in NLP context, not a lot of people are doing this, compared to how much this kind of things are being done in computer vision. So there's actually a lot of work to be done in this case. Now, in terms of the workflow, there are two different steps, as you can see, actually three, right, that we have discussed: providing explanations to humans, human give feedback, and then we fix the model, right? We improve the model. I mean, this is one way of looking at the workflow. There are other ways of looking at the workflow as well. There's another type of categorization, right? About the different steps in the debugging process. One is what Agatha was mentioning, right? We can have proactive debugging and reactive debugging. Proactive debugging meaning before we observe all these kinds of errors, right? Can we have a way of getting insights of where things can potentially go wrong? Huh? Can we do that? And reactive meaning, oh, after we observe some errors, right? What do we do in the debugging? So these are two different scenarios that can that can happen in the debugging process. That's another angle, right? And if we talk about the workflow, I think that can be more fine-grained. There's a work that Agatha and I are doing on really make the steps very concrete for debugging a computer vision model. That includes requirement gathering, includes explaining or understanding the model behavior, and the interaction between those two, right? If we wanted to for example, if we aim at coming up with a very cost-efficient way of debugging, then there are all these things that we would like to consider in order to optimize for the cost, right? This might be too much, and I'm not sure if it's good to bring too many things from our own. But what I want to say here in general is that workflow is it can be either very coarse-grained or fine-grained. It can be if we want to go deep, it can be made of a workflow can contain concrete operations that the humans take, that the machines take, right? So a lot of space for interpretation here. And what the authors discuss here in this paper is, well, different aspects in terms of providing explanations, in terms of providing feedback, right? For example, in providing explanations, we need to consider different scopes of explanation. So for folks who are very familiar with explanation literature, right, we usually talk about the two types of explanation, local and global. Local means we want to explain model behavior with respect to a single instance. And global meaning we want to explain the general behavior of the machine with respect to, for example, a class in a classification problem. And that involves model behavior in a lot of the instances, of course, right? So it's a much broader scope. There are pros and cons, right? When we want to debug the model using local or global explanations, there are pros and cons. Local explanation, of course, since it's per instance based, right? If the humans need to go through all the different instances, it takes a lot of effort, right? So the effort is a concern there, but it gives more insights. It can give more refined insights of how the model is behaving. And global explanation is, well, on the other way around, right? It can hardly review how exactly the model is behaving, right? Especially when the behavior is complex. Global explanations might not be able to provide much insights into that, but it can save human efforts, right? So there is a sweet spot in between, actually, that we can have a nice balance between the human effort and also the amount of insight that the humans can gain, right? And this is what the author advocates. If you look at the paper, right, there is this scope of explanation in between local and global that basically is like a subset of the class, right, or certain instances that share common features. These are actually quite interesting, I think, for us as well. We've been talking a lot about unknown unknowns, for example, right? And those unknown unknowns, usually they can be characterized by, common features using human language, described by concepts, right? And this group of instances where the model generates errors are the ones that I think we should be most focused on. And this is not, I mean, if we think about the scope, right, it's not the one instance, it's a group, right? It's a group instance that can be characterized by common characteristics. And it's not a class, right? So it's somewhere in between. And that will be very interesting. That will be very interesting. I think a lot of work that we've been doing is exactly on this level, right? Akash is smiling, yeah. Right. A lot of things that we have done, I think is also worth looking at in NLP context. And then about the explanation being generated, there are different types that we also already talked about. Oh yeah, and then how do we present the explanations to humans, right? This is more HCS stuff. This is more interactions. So here we need to consider many different factors, right? What kind of knowledge the humans have, what kind of background that they have that might affect the intake of the explanations, right? What are their desires? What are their limits, right? As we have discussed about that, right? There are all different types of forms of explanation that we can provide to the people, but it might not all easily consumable by them, right? So it's important to make the explanations user-friendly, but of course, there are other, desirable properties that we wanted to have in general for explanations. That it should be sound. In this case, what it means is high fidelity, right? That the model, that explanation really describes how the model is behaving faithfully, right? We want to have an explanation that not only makes sense to humans, but also can describe the real behavior of the machine learning systems. complete. So we don't want to miss, we don't want to miss any important explanations of model behaviors. So we don't want to miss certain behavior that might require inspection, right? We want the explanation to be complete, not overwhelming, right? And this is, I think, is similar to user-friendly. If we consider if we consider how humans can take those explanations. I'm not sure if I want to go too much in detail in these cases, in these slides. There are different types of feedbacks human can give, right? Words, importance of those words, right? Or sometimes the rules, anyway, or learn features, right? Anyway, so there are different types of feedback humans can give. And this this form of feedback, right, that could also be we may also need to make it differently for different types of NLP tasks, right? Sometimes it's more complex than individual words. For example, if it's question answering task, we might want to know more about human would reason in the different logical steps, right, in order to reach an answer, right? So this is also an open question, right? How do we so what kind of forms are suitable in which kind of tasks, right? For which type of people involved? So there are all different things that we can look into. These are open research questions, and then updating the model. I've been talking about that as well, right? Once we know the feedback provided from the humans, how do we update the model? There are different ways, right? Adjusting model parameter, improving training data, influence the training process, right? Blah, blah, blah. So if you're interested, you can go and take a closer look at the paper. Workflows. Yeah, I don't think I want to talk about that. Yeah, experimental setting, right? This is interesting. The authors discuss about different settings that we can do in this kind of research, right? We need humans, especially in that part, right? We need humans, but what kind of humans do we need? And in which setting, right? We can have participants, those subjects that we can interact with in an in-house setting, right? And there we can observe how the participants interact with the explanation or debugging method, how they interact with the machine learning model. And by doing that, we can gain, I think, deep insights about the human-computer interaction. But on the other hand, it's of course limited that, okay, usually we cannot have a lot of subjects or participants involved, 10, 20, 30 maximum, I think. So there is a limitation on this kind of methods. We can scale it up, going to those crowdsourcing platforms that would allow us to conduct experiments at large scale. But then quality control is a problem, right? Quality control is always a problem here. I mean, we have less control of how the process will goes, and the workers are sitting in front of their own screen that we don't know what's happening. So we have a less control there. There's a limitation, right? And the most economic way would be do some simulation, right? Where we simply assume there's a perfect human subject oracle that gives us perfect answers, perfect feedback. And this is fast and cheap, right? And then, of course, well, I mean, these are not real humans, right? We cannot really test or experiment much on the interactivity side, but rather, I mean, this is useful if there is some system side of the debugging method. If we want to test that, right? This kind of method is useful there. But yeah, it wouldn't fit if we want to study all these human factors, right? A list of papers the authors went through. And now, when we talk about the human factors, the authors also look at a lot of interesting dimensions, right? How explanation or debugging influence the people, how that influenced the people. first of all, how that influenced their understanding of the model's inner working mechanism, right? And also has some interesting findings like, oh, rule-based and keyword-based methods are better than those example-based explanation methods. And we needed and for the explanation to be effective, it should not only explain why the model is behaving like that, but also explain why not the model is behaving in a certain way, right? And this is more useful for the humans to provide feedback if we compare the two either of those alone, right? So only explaining how the model is doing or explaining why the model is not behaving in a certain way. And of course, interactive explanations are more useful than static, right? If the users can somehow play with the explanations a bit, it would increase the understanding or the feeling of understanding of how the model works. So some interesting findings. Yeah, and then, yeah, okay. This honestly, I don't really understand quite well, even when I was reading the paper, but this is interesting. So, and I think it's intuitive as well. If we are able to review the inner working of the model, we can gain a better understanding of how the model works and help, help humans will get a better understanding. But then on the other hand, it also introduces additional workload, right? Because now the human are asked to understand more. Makes sense, right? Willingness. Let me see what it means. Okay, I need to look at the paper again. Willingness. Oh yeah. So yeah. So our goal is to solicit human feedback, right? But are humans really want to do that, right? We need to consider how willful they are in providing the feedback, and that most probably. Oh, some interesting finding is that humans don't want to look only at the labels. And a lot of the feedback they provide are actually related to the common sense knowledge, and that's related to scholars' work, right? And the knowledge about English language. So it's not that they can provide any feedback, right? They have their tendency of certain types of feedback, and a lot of the cases are related to common sense knowledge. If we wanted to get more things from the human subject, we might need to design the task in a better way. And there are some limitations of human feedback. It's neither complete or precise. I mean, we here doing crowdsourcing or human computation studies, we all know that, right? Humans are never fully reliable either, right? It's not only machines, but also humans who are not reliable. And one interesting finding, I think that's something that we have also been talking about, is that it's hard for humans to provide numbers, to give quantitative feedback. Like, okay, on a scale of 0 to 10, right? How important this word should be in the classification of this sentence, right? Usually, it's hard for humans to provide this kind of feedback. Yeah, of course, then they cannot provide the probability, and some people might even don't know what probability means. But what's interesting here is that humans can usually provide the causal relations, how one certain feature is related to a certain decision, right? What's the cause and effect, right? This kind of relation, the humans are usually good at provide. And that also makes sense, right? And what's interesting here is that machines are not good at that. So this is also a reason why we want to have humans on board. Right? Now, trust. Trust, a complex term that we talk all the time. So all these explanations and debugging activities that humans are involved, right? They can influence humans' trust towards the model, right? And there are, I mean, and then there are things that we do differently can either increase or decrease the trust. And for example, the orders find, okay, if we show more detailed explanation, we can increase trust, but we cannot increase the trust if it's a high stakes context, right? So there is a limitation of those of how explanations can affect users humans trust, and that is dependent on the context, right? What kind of applications tasks we are considering here. The ability. Oh, and another very interesting point that that I get from this survey is that if the humans are able to provide feedback, the trust can increase. That's interesting, right? If the humans, they have some autonomy and they feel that they have made a contribution to that's my interpretation, right? A contribution to making the model better, it will increase their trust. This is a very interesting point.
One of the reasons, to jump in there, that tends to happen in human AI decision making is because of the notion of perceived learning ability of a system. So in some related works, right, where people have explored trust in human AI collaborations, what was found was that if you're interacting with the system and you provide some feedback and you can perceive that this feedback is actually helping the system,
yeah,
that can go a long way towards overlooking really poor system accuracy as well, right? So as long as there is some perception of a learning system, so this might also be related to that.
I see. Yeah. I feel that this must be very connected to some findings in HCI, right? So yeah. Now I noticed there is this providing feedback decrease human trust. Okay, I don't remember. Oh, I think it's for low quality models. Yeah, it also depends. So for some low quality models, humans providing feedback might even decrease their trust. This is interesting also, right? Maybe this could be interesting as well from HCI perspective. Like the effect of providing feedback on human trust is dependent on not only, on multiple factors, right? It looks at what the authors find here is that was for high quality models, it's useful. Well, something where the model truly, no matter where the model.
Yeah, so
okay, yeah.
So I think this is about the quality of the models and how your explanations would contribute to understanding the model, right? So as you intuitively, you could imagine that by providing explanations, you reveal that a system's pretty good, or if it's pretty good, then that would increase trust. But as a function of your explanation, if you reveal that it's a low quality model, it would obviously decrease trust, right?
Yeah. That's interesting. That's interesting. If the human feel, okay, this is so bad, right? After the while they are entering those feedback, they might, this might even lower down their trust. Cool. Yeah, and then the author started to discuss about the frustration, right? Okay, when there's a lot of poor explanations, too many details, and the users might feel exhausted, right? This is the frustration and expectation, right? So the participants usually would expect the model to behave after the provide the feedback, and that might not be the case, right? So machine learning is hard to say anything like that. Okay, the model will improve before we really observe that. So it's important in this case to manage the participants' expectation in this case. Okay, I'm taking a lot of time. I'm mostly done here. Summary, open problems. We've been talking about all these things. So I will conclude here.